for your first lesson for Module C, we are going to talk about Section 4.5, Solving Quadratic Equations by Finding the Square Roots. First of all, we're going to review how to simplify and work around the square roots a little bit. You guys should be experts at this because we just finished up trigonometry where we used it. Little terminology here for you guys. A radical, you guys should know that. We are referring to something in the square root. The thing underneath the square root, we're going to call that the radicand. Okay? You're not expected to know that terminology, but if I refer to it in class, you're going to want to know what I'm talking about. Two properties down here. The product property with radicals. If you are multiplying two terms in a radical, we can split them up into two different terms, and it works the other way too. If you have two radicals that you want to multiply together, as long as they're both underneath a radical, you can multiply it. So for example, radical 18 is equal to radical 9 times radical 2. Same deal. If I wanted to multiply radical 9 times radical 2, I would just multiply the numbers and stick a radical over it. And then of course we want to write it in simplest radical form. Same deal goes for the quotient property, which we have talked about in class a little bit. If we want to take the square root of a fraction, we take the square root of the top and we divide by the square root of the bottom. And again, if I want to divide two radicals, I can pull out that radical sign too. So please make sure these get in your notes somewhere. Alright, so to simplify radicals, and this is something we've talked about in class, your radical is simplified if the radicand has no other perfect square factor than 1, and there's no radical in the denominator. Really helpful thing here, guys, is to write your perfect squares out. It really helps. So what I would do is I would start with 2 squared and just write it down on your paper. We would write 4, 9, 16, 25, 36, 49, oh, we forgot 64, 64, 81, 100, 121, and so on and so forth. Okay? If you have your perfect squares on the side of your paper, it's very easy to take something you're trying to simplify and check it. So for example, let's simplify radical 80. What I'm going to do is I'm going to go down my list. I'm going to say, what is the biggest perfect square that 80 will divide into? So I might start with 4. Well, I know 80 goes into 4, and I'm going to circle it. But it might not be the biggest. I'll keep going. 9, no, 16. 80 does go into 16. Then I'm going to keep going. Okay, we're getting a little high here, guys. I think that's it. So the biggest perfect square that goes into 80 is this 16. So then I'm going to check it. I'm going to go 80 divided by 16. I get 5. So that tells me I can rewrite radical 80 into radical 16 times 5. The one that you can take the square root of gets pulled out. We can take the square root of 16, so that one gets pulled out of my radical. And I rewrite that as 4, because I took the square root of 16, radical 5, because I did not take the square root of that, since that would give me a decimal. And that is my simplified expression. B here, we have an example of our product property. Okay, we have two radicals that we want to multiply. They're both in radicals, so I can just multiply the numbers. I'm going to do 21 times 6. I say that's going to give me radical 126. Now that's a pretty big radical. So what I'm going to do is I'm going to take 126 and I'm going to divide it by each of my perfect squares and see what is the biggest one it'll go into. When I do that, I figure out that I can rewrite radical 126 as radical 9 times 14. 9 is the biggest perfect square that will go into 126. I'm going to take the square root of the 9 and pull it out. So that tells me I can rewrite this one into 3 radical 14. Okay? Letters C and D are examples of our quotient property, we want to take the square root of this fraction that is the same as taking the square root of the top divided by the square root of the bottom. And then I'm just going to do those square roots. Square root of 4 is 2. Square root of 81 is 9. Same deal with this guy. Square root of the top divided by the square root of the bottom. Radical 7, not a perfect square. So I'm just going to leave that as radical 7. Radical 16 is definitely 4. I'm going to check to make sure I can't rewrite radical 7. There's absolutely no factors that can go into 7, and there's no radical in the denominator, which you guys are awesome. You already know about. So I'm done. If you need to see more of that, you can check in your textbook, or you can replay this. Bring your questions to class, but this should be kind of familiar since we just did this stuff in trigonometry. Okay, now we're going to talk a little bit more about